Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is Measures of Dispersion Standard Deviation Part 2 video. In our previous video, we started with the definition of standard deviation and computation of standard deviation for ungrouped data. We were discussing two methods in our previous video. Same as the previous video, in this video we are going to discuss two methods. Long method or direct method, and the second method is shortcut method. In this video we are going to discuss about grouped data. Okay, let us start an example. I'm going to start with the first method, direct method. Like our part 1 video, we discussed ungrouped data. Here in this video we are going to start with grouped data. So let's see the computation of standard deviation for long method or direct method. This is the formula we will be using in this problem. Okay, let us take an example. Find the standard deviation for this distribution. A set of class interval is given and also a set of corresponding frequencies are given. Same as our previous example, examples we discussed in part 1 video, we are going to write all the details in a tabular form so that we can do all the calculation without any mess. Here also, the first step is to find the mean m, for which we have to take the midpoints of the class intervals. It will be denoted by x, and we are going to find the product f of x. Okay, let's see the steps. These are the headings that we are going to use in this problem. So I'm going to enter all the class intervals given in the question in first column, and I'm going to enter the corresponding frequencies given in the question in the second column, and third column is the midpoints of the class intervals given. So how do we find the midpoints? We just add the lower limit with the upper limit and divide it by 2. Can you follow so far? So same way you have to find the midpoint for each of the class interval given. And for the fourth column, we are going to write the product of the values in the column number 2, f, with the corresponding values in column number 3, x. So it is just the product of all the numbers. And D is where we are going to find the mean. After finding the mean, we will just subtract mean from each of the midpoints. And D square is obviously squaring the values we got in this column. And FT is product of F and D square. So this is how we are going to fill in each of the column of the table. So let's enter the class interval. I have entered all the class intervals given in the question starting from 18 to 20. Can you follow so far? Now let's enter the corresponding frequencies given in the question in column number 2. Hope you're clear with column number 2. And now let's find the midpoints. 18 plus 20 divided by 2. That would give you 19. Am I right? Same way for the second one. 15 plus 17 divided by 2. That would give you 16. Same way you have to find the midpoint for all the class intervals given in column number 1. So you have to enter the midpoints that we will be finding in column number 3. Can you follow so far? Now let's fill in the column number 4. Just multiply the corresponding values in f and x column. 3 times 19, 5 times 16, 6 times 13. So it goes on like this. And for the final one, 1 times 1. Please check whether you're getting the same set of values. Okay. Now let's fill in next column D. Before that, I'll be finding the mean. To find the mean, I need the sum total of f and sum total of f of x, because mean is nothing but summation of f of x divided by n. N is nothing but sum total of f. So here is the sum total. I'm getting 333 for f of x column and 30 for f. So mean would be 333 divided by 30. So mean for this example is 11.1. Hope you're getting the same value. So now we are going to find the deviation. Deviations of the midpoints are to be taken from 11.1. So subtract 11.1 from each of the values in column number 3. So 19 minus 11.1, 16 minus 11.1, 13 minus 11.1. Can you follow so far? This is how we have to fill in this column. Now let's calculate D square. We are getting some negative values here. We need to get rid of that. So that I'm taking D square. So just square the values we got in deviations column. Can you follow so far? 7.9 the whole square will give you 62.41. Same way you have to square each of the value in D. Now let's fill in the last column, FD square. Before starting all the calculation, you fill in the heading for the table so that you will not miss any calculation. Okay, first midpoint, fx, deviation, d square, ft square. So ft square, from this heading itself you can understand that we are just going to multiply the values we have in frequency column along with the corresponding values we got in d square column. So 3 times 62.41. So when you're multiplying like this, please don't mess up with the values we got in other columns. We have there are some chances. Initially, before getting practice, students may confuse with the values in the column. So that be careful. So you can just use some highlighter for the columns. So 3 times 62.41 will give you 187.23. Like that, you can multiply the values in the F column and D square. You can just use a pencil and draw an arrow here so that you can multiply correctly. Okay, let's fill in FD square column. Hope you're getting the same values. Okay, even for this one we need the total, because hope you remember the formula I showed you initially. We will be using summation of fd square divided by n. We have already got the n. N is nothing but sum total of f. Hope you're getting 674.70. Okay, now let's use this value in the formula. So let's calculate the standard deviation. Here is the formula. Plug in the values we got from the table. Replace summation of fd square by 674.70 and n by 30. Please check whether you're getting 4.74 for this example. So this is the required standard deviation for this example. Hope you're clear with this example and the steps in computation of standard deviation for the direct method. Okay. Long method is another name for direct method. Sometimes in this direct method, it is observed that the deviations from the actual mean, the mean we are getting, we are just subtracting it here, no? So that thing, that results in decimals. Even here we got some decimals, and the values of d squares and ft squares are difficult to calculate. Am I right? Because again and again we are getting decimals here. In order to avoid this problem, we follow the next method, which is called shortcut method for calculating standard deviation. So let's see an example for shortcut method. In this method, instead of taking the deviations from actual mean, we take deviations from a suitably chosen assumed mean. Assumed mean is denoted by AM. Assumed A, mean M. Okay, this is the formula we use for calculating standard deviation in shortcut method. So from the formula itself you can understand the difference between the previous one, direct method and shortcut method. Here this D is nothing but deviation from assumed mean. First let me explain you the steps that are involved in the computation of standard deviation. As a first step, we will be obtaining deviations of the variates from assumed mean. So I'll be giving you the formula. D is, in our previous method we find the mean, but here we just take an assumed mean and subtract the values from the x and multiply these deviations by the corresponding frequencies to get the column FD, and we will be finding the sum total of the column FD with the corresponding deviation D, and multiply to get the value FD square, same as the previous method. The sum of this column would be summation of FD square, and we will be using this formula to find the standard deviation. So just by looking the formula you can understand that you will need D square and sum total, D and sum total, and N. Okay, let's do an example. You will understand the steps clearly. Let's take the previous example itself for this one too and do this method. Here is the example. Now I'm going to show you the calculation in tabular form. These are the headings we will be using in the table: class interval, midpoints, frequency, deviation from the assumed mean, FD square. I have done the calculation already and the assumed mean is going to be 10. I'll explain you how I have taken the assumed mean from the values given. Let's enter the class intervals and frequency. Class interval in column number 1 and frequency in column number 3. Enter the class intervals along with the corresponding frequencies. Now let's find the midpoints. Midpoints is same as the previous example. So here, as we are taking the same example, you need not do the calculation again. You just have to add the lower limit along with the upper limit and divide the answer by 2. This is how we find the midpoints, same as the previous example. Now I'm going to take an assumed mean here. we have totally 7 values here. I'm just going to take the middlemost one. In case if you're getting two middlemost numbers, you can pick the one that is larger. Okay, here I'm getting 10. This is going to be my assumed mean. Do you note the difference between the previous method and this one here? There we do the calculation to find the mean, summation of f of x divided by n. But here we are just directly taking one assumed mean, so that we can ignore all the decimal values that we are getting in this column. And if we are getting decimal values in d, obviously we will be getting decimal values in fd and fd square. Because if you are rounding some value, you will be getting the answer that are very closer to the accurate one, not the approximate one. Okay, let's fill in D column. We are just going to subtract this 10 from each of the midpoints. 10 minus 10 is 0. I'm getting few positive numbers above 10, above 0, and negative values below 0. 19 minus 10, 16 minus 10, 13 minus 10, 10 minus 10, 7 minus 10, 4 minus 10, 1 minus 10. Hope you're clear with this calculation. And now let's fill in the next column, FD. FD is nothing but product of the values in column F and D. 3 times 9. So while you're doing the calculation, please be careful with the negative sign. Please don't ignore the sign. 3 times 9 is 27. 5 times 6 is 30. 6 times 3 is 18. 0 times anything is 0 again. So multiplying, I'm getting these values. Hope you're getting the same values. Okay, now let's find fd square. If you want, you can include one more column d square to show the calculation, or you can just directly multiply fd square. 3 times 9 square, 5 times 6 square, like that. So by multiplying, you can fill in the last column. See, from the assumed mean we did the calculation and we got some whole numbers, not any decimals. So that's the important difference between the direct method and shortcut method. Okay, now let's put all the values from the table in the formula to find the standard deviation. Before that, I'm going to find the sum total of F column, sum total of FD, sum total of FD square, because these are the values we'll be using in the formula for standard deviation. Sum total of F is 30. Sum total of FD is 33 and sum total of FD square is 711. These are the values I'm getting as summation. Now here is the formula we will be using for the standard deviation computation in shortcut method. So let's plug in these values. Here you should not mess up with this formula. FD square and here FD within the parenthesis. Just plug in this value divided by 30 and take the square. Okay, so let's plug in the values. Divide 33 over 30 and take the square, and divide 711 over 30, subtract the value from this one and then take the square root. For this one I'm getting 23.7. 33 over 30 is 1.1. 1.1 the whole square is 1.21. So 23.7 minus 1.21. Finally take the square root of the answer that you're getting. Here I'm getting 4.74. We are getting exactly the same answer we got in the previous method. Hope you're clear with this method also. Okay, we can continue the same topic in the next video also. We have step deviation method, one more method to find the standard deviation. We can see the computation of standard deviation even in that method, step deviation. And we have to discuss some properties of the standard deviation also. And I have to discuss combined standard deviation. You should also know about combined standard deviation. Okay. Hope you're clear with both the examples and both the methods. In case if you have any query regarding the computation, kindly let me know. See you in the next video.